the triaxial test, or more specifically, the unconsolidated undrained triaxial test. The triaxial test is based on a principle in which a cylindrical sample of soil is either compressed or extended. The compression test is a common version of this test, while the extension test is far less common. The idea that compressing or extending a sample's soil can actually lead to shear stresses. In order to control the cell pressure acting on the sides of the samples, the entire sample is housed within a watertight enclosure, which is often made from perspex. The space between the sample and the enclosure is then filled with water, which is a medium through which the cell pressure is transmitted. For this experiment, you will require a sampling tube, the triaxial cell, a split mold, 4 O-rings, a membrane stretcher, a suction device, a pair of porous stones, a pair of filter paper, a top cap, a supporting block, as well as a pair of vernier calipers. Grease the inner wall of the split mold. Then, measure and record the weight of the brass split mold. Following which, measure and record the length and diameter of the mold. Clamp the split mold onto the extruder. Then, insert the sampling tube into the extruder and slowly extrude the soil sample into the mold. Do this until the entire length of the mold has been filled by the soil sample. Cut off the soil sample using a wire cutter. Then, trim it so that the two ends of the sample are flush with the ends of the split mold. Measure the weight of the split mold and the soil sample. This is to allow you to determine the unit weight of the soil. Then, extrude the soil sample by pushing the supporting block into the mold. Take the membrane and cut it by about 3 centimeters. Next, check for tears in the membrane by stretching it. Stretch the membrane over the membrane stretcher provided. And use the suction device to suck out the air from the membrane. Finally, slip the rubber membrane over the sample. Moisten the two pieces of filter paper. Then, place them on both ends of the sample. Now, place the two porous stones on both ends of the sample. Position the specimen on the pedestal. Attach the suction device to the membrane stretcher. And pull the membrane out of the membrane stretcher. Stretch the 4 O-rings over the membrane stretcher. There should be 2 rings at each end. Now, place the membrane stretcher over the specimen. Slide the O-rings down to fasten the O-rings onto the pedestal. Place the top cap over the specimen. Again, place the membrane stretcher over the specimen and fasten the O-rings in a similar manner. The O-ring should be placed on the top cap. Take the triaxial cover and pull the loading ram all the way up. Then, place the triaxial cover over the base, taking care not to knock the soil specimen over while doing so. Allow the loading ram to slide down slowly until it sits centrally on the top cap via the ball socket seat. Then, tighten the nuts that hold the perspex cover onto the base. Put the entire triaxial cell onto the loading frame. Ensure that it sits in place. Then, raise the platform until the top of the loading ram just touches the proving ring. Ensure that the loading ram is not in tight contact with the proving ring. Otherwise, there will be a preload on the sample. The proving ring is a device for measuring force or load through the deformation of the steel ring, whereby the load applied onto the sample is obtained by multiplying the value shown on the gauge by the proving ring calibration factor. Connect the cell inlet to the high pressure water supply using a spanner. To fill up the triaxial cell with water, increase the pressure by turning the knob clockwise to about 0.5 bar or 50 kPa. Then, open the 2 valves and water will start filling the triaxial cell. Once the cell is filled, water will flow outwards through a small opening at the top of the cell. When this occurs, close the opening by tightening the nuts. Raise the cell pressure to the prescribed levels of 100 kPa, 150 kPa, or 200 kPa as instructed by your lab teaching assistant. Then, adjust the dial gauge onto the dial gauge support. Zero the reading on the dial gauge by rotating the frame. Also, zero the reading on the proving ring. Set the loading frame to a speed of about 1.5 mm per minute. This gives a strain rate of 2% per minute, and you are ready to start the test. Start the test and record down the force gauge reading on the proving ring as the sample is being compressed. Do this at the intervals specified in Annex B until the gauge reading registers 1,500 divisions. After the test is over, move the base of the loading frame down to its lowest position. Decrease the cell pressure to 0 by turning the knob anti-clockwise. Next, open the opening at the top of the cell to allow water to drain out. Once the triaxial cell is empty, close both valves. Then, disconnect the water line from the triaxial cell using a spanner. After the test is over, dismantle the cell by loosening the bolts. Move the loading ram up by pulling on it. Then remove the triaxial cell cover. Take out the O-rings, followed by the top cap and the porous stone. Take the sample out from the pedestal. Slice off the top part of the sample. Then, take 3 slices and put them in the dishes for the water content measurement.